Okay, so in this question we're given a word problem, and in part A we need to form a differential equation from all these information given, and in part B we need to solve the differential equation and then use it to work out a time. So let's begin part A. So we're given a cylindrical water tank, and the diameter is 6 meters, and we're told that water is flowing into the tank at a constant rate of 0.48 pi. So we're going to write that down in terms of symbols. If you look at the units, it says meters cubed per minute. So that's meters cubed is a volume, and per minute is per unit time, per time. So that's dV dt, the rate of change of volume with respect to time, and we're told it's flowing in. So we can put that down as dV dt equals positive 0.48 pi. So positive because we were told it's flowing in. Okay, so we're also told that time is t and depth is h. And at the bottom of the tank there's a tap, and water's flowing out at a rate of 0.6 pi h meters cubed per minute. So that's also a rate of change of volume with respect to time, and it's flowing out. So as well as water flowing in, we have to minus off the water that's flowing out. So that's minus 0.6 pi h. So that's all the information given here. That's everything is down here. And part A, we need to work out dH dt. So at the moment we've got dV dt, but we want dH dt. So the easiest way to do that is begin by what we want. So we want dH dt. So dH dt, and we're going to use the chain rule to input the letters that we want that are missing. So we only have a H and T here, but in the problem we have a V. So we can input a V using the chain rule. So we get dH over and times dt. So that's this dH dt, one on the top, one on the bottom. And then we input the letter that we want. We want a V. So let's put a dV and a dV there. So that's the chain rule. And we just have to fill out these two. So dV dt, we've already worked that out. That's over here. That was given. So we just have to work out dH dV. So in order to get that, we need to get a formula that links the height and the volume. And if we look at the shape that we've got, it's a cylinder. So there's a formula for the cylinder. So we know that the volume of a cylinder is pi r squared h. It's the cross-sectional area, that's the base, which is pi r squared, times the height, that's the depth. And we know that the radius is 3 meters, so this should equal pi times 3 squared h. So we get V equals 9 pi h. So that's the formula linking volume and height, and we can use that to get dH dV. So we're first going to get dV dH through differentiation. So dV dH, if we differentiate this we get 9 pi, and we want dH dV, so we're just going to flip this upside down. So therefore dH dV should be 1 over 9 pi. So we now have everything we need. We can now just fill this in. So we get dH dt equals, so it should be dH dV, that's 1 over 9 pi, times dv/dt, and that's the information that was given. So that would be timesing 0.48 pi minus 0.6 pi h. So we'll just simplify this. So the pi's cancel on both, and we can just divide both of these terms by 9. So we have 0.48 divide 9 gives us 4 over 75 minus, and we have 0.6 divide 9 will give us h over 15. So we have dh dt is 4 over 75 minus h over 15, and they want it to look like this. So there's a 75 in front of the dh dt, so all we have to do is multiply everything by 75 and we should get the answer. So we'll times this by 75, so you get 75 dh dt equals, so 4 over 75 times 75 is just a 4, and h over 15 times 75, or 75 over 15 is a 5, so this gives us 5h. And that's part A done. So part B, they've given us, we need to work out the value of t when h is 0.5. In order to do that, we have to first solve the differential equation. Once we've solved it, we can plug h as 0.5 in. Okay, when we solve this, we are going to get a plus c, so they've given us some information to work out the plus c. So t is 0 when h is 0.2, we'll jot that down. So when t is 0, h is 0.2, and then we can solve the differential equation now. So the first step is to multiply up the dt. So this is a separable differential equation. At the A level, we only have separable differential equations, so we should be able to get all the h's to one side and all the t's to the other side. So we'll first times up the dt. So we have 75 dh equals 4 minus 5h dt. So this means that we want to get the h's on the left and the t's on the right, so we better divide by that term there. So we get 75 over 4 minus 5h dh equals 1 dt. And now that we've separated the h's and the t's, we can now integrate both sides separately. So we have integral here, integral here. So the integral of this side should be an ln, so we get 75 ln mod of 4 minus 5h, and then we have to divide by the coefficient of the h, which is a minus 5, so over minus 5, and that should equal t plus c. And we'll just simplify this a bit. So this is a minus 5, so therefore we get minus 5 ln 4 minus 5h equals t plus c. And at this point, as soon as we get the plus c, we should work it out straight away. So we'll sub in t is 0 and h is 0.2 to work out the c. So minus 5 ln, let's plug a 0.2 directly in. I'll just use the calculator. So 4 minus 5 times 0.2 is 3. And that should equal 0 plus c. So therefore, c equals minus 5 ln 3. ln 3. Okay, so let's put this into this equation here, just to get the equation. So therefore, minus 5 ln 4 minus 5h equals t minus 5 ln 3. And we don't need to actually make h the subject. We don't need to solve this for h. We just need to work out t when h is 0.5, so we can just plug 0.5 in straight away and rearrange it for t. So we're told that h equals 0.5, and we're going to sub that in. So we get minus 5 ln, and let me plug 0.5 in here with the calculator. So that's 4 minus 5 times 0.5. That's 3 over 2 equals t minus 5 ln 3 is and it's actually not a 5. I believe 75 over minus 5 is a 15, so that's a 15, 15, that's a 15, and a 15 and a 15. So we get a 15 here, and there was a 15 there. So this is the correct equation, and we can solve this for t. So we get t equals 15 ln 3 minus 15 ln 3 over 2, and we can simplify this. 15 is we can factorize out the 15, and we get ln 3 minus ln 3 over 2, and we can now join up the logs. So that's 15 ln, and to subtract two logs you divide the two numbers, so 3 divide 3 over 2, that equals 2, so this is ln 2. So t equals 15 ln 2.